When we watch athletes in motion, we are seeing billions of individual living cells working together in a massive synchronized effort. Think of your body as a bustling city. For a city this size to function, its citizens need to communicate constantly. But your cells don't have the benefit of phones or internet. Instead, the body relies on a specialized chemical postal service. These messengers are called hormones. They are carefully packaged and dispatched by centers called endocrine glands, which act as the hidden sorting facilities for your internal city. Once a hormone is released, it merges onto the body's massive superhighway, the bloodstream. This allows these messengers to travel from their starting point to organs on the complete opposite side of the body. Without this long-distance communication, your body would fall into quiet isolation. Simple tasks like digesting a meal, or even growing taller, or preparing to run from danger would be impossible to coordinate. To understand how this works, we have to look at the difference between the two most famous chemicals in your body, hormones and enzymes. Enzymes are local workers. They specialize in speed, ensuring that a chemical reaction, which might normally take hours, happens in a fraction of a second. They do the physical labor, and they stay right where they are made. In this comparison, the enzymes on the left are rapidly assembling parts in one spot. But on the right, the hormone is a traveler. It doesn't build anything. It moves across a long distance to deliver specific instructions to a destination far away. Think of enzymes as the mechanics physically turning the wrenches in the shop. Hormones are the managers sending out the memos that tell those mechanics exactly when to start and when to stop. Since hormones are floating through the general currents of your bloodstream, we have to look at how they manage to find one specific organ out of hundreds. The answer is that the cells designed to hear the message are the only ones with the right hardware. These target cells have specialized docking stations on their surface called receptors. As the hormone floats along, it ignores millions of cells because their receptors don't match. It only stops when it finds a docking station that provides a custom-molded fit for its specific chemical shape. This specific matching system prevents internal confusion. It ensures a signal intended to help you digest your lunch doesn't accidentally tell your heart to start racing. Not every messenger delivers its memo the same way. The first group, called peptide hormones, includes familiar names like insulin and growth hormone. Peptides are made of amino acid chains, and their most important trait is that they dissolve easily in water. But cell walls are made of fats. Since water and fat don't mix, the water-soluble peptide bounces off the boundary. Instead of entering, the peptide docks at an exterior receptor, triggering a reaction that passes the message through the wall, like shouting through a closed window. This doorstep delivery allows the hormone to control the cell's behavior from the outside without ever having to breach its physical defenses. The second group, steroid hormones, works by a different set of rules. This group includes testosterone and the stress response hormone, cortisol. Unlike the water-soluble peptides, steroids are made from cholesterol, which makes them fat-soluble. Being fat-soluble, the cell wall isn't a barrier. The steroid dissolves right through the membrane, gliding straight into the cell. It travels to the nucleus, the command center, and binds directly to the cell's master instruction manual, the DNA. By reaching the master manual and changing which instructions are read, steroids have the power to change what the cell actually builds, creating deep, long-term changes in your body. There is a third group called amino acid derivatives. These are smaller, simpler messengers built from single building blocks. The most famous of these is adrenaline. It acts as the body's rapid response emergency messenger, creating the explosive burst of action you see here as a sprinter leaves the blocks. No matter their shape, these messengers are organized into teams. Some manage your growth, others handle how you burn energy from food, and others prepare you for high-stress moments. Having these different types of messengers allows your body to run slow, decades-long projects like growing your bones, while simultaneously handling split-second emergencies. All of these millions of traveling messages are sent for one primary reason: to keep your internal environment stable and steady, no matter how much the world around you is changing. If this delivery network fails by sending too many messages or losing them along the way, it leads to serious issues like diabetes or growth disorders. The next time you feel a sudden surge of energy, a wave of hunger, or the quickening of your pulse, you're feeling the success of this system. It's the sound of a chemical message being delivered exactly where it needs to go to keep